Alright guys, it is the next morning. Welcome back. All we have to do is pull our main line from the breaker panel all the way over, tie it into an outlet, and then that line on each circuit will be properly powered. So we have some work to do in the electrical panel, which leads me to the electrical panel. It's a disaster. There's all kinds of breakers in there that are connected to stuff, but I have no idea where they go, and there's not that much power in the shop. As we discussed, we're adding a lot of power in the back. So I kind of know where everything is, and then we have these mystery breakers that have leads coming out of them that are powered, that don't really power anything. So we're going to take care of that. It's a safety issue to have live wires that aren't connected to things that you use or know where they're connected to. So we're going to go ahead, get rid of all the crap out of the electrical panel that doesn't need to be there, free up some room, and then put in our tandem breakers. Now, like most panels, this panel looks absolutely disastrous. Wires are running everywhere in every different direction, and they're not very uniform. So to show you what my panel does look like in my house that I rewired, this is what you should expect to see when you pull off a panel, and not this. So as you can see, there's wires everywhere. There's 3 breakers that I kind of popped out of their place because I don't know where they go, and that's something I want to go ahead and remedy while we're in there trying to fix the back half of the shop. I'm not going to rewire the entire panel, but everything that I have no idea where it goes should be removed for safety concerns. You should always know where your breakers connect to, because if you don't, that's a fire hazard. So we're going to go ahead and take care of all of that. I'm not going to film it because I am going to cut power to that panel. Maybe I'll show you the after effect, or what it looks like after. And it's not going to be as pretty as my house panel that I showed an example of, because we redid that entire panel, and that's the kind of OCD that takes place when you're redoing an entire project. I don't have time to redo the panel right now. I just have time to work on the section of shop that we're working on. Maybe we'll get to the rest of the shop at a later date, and maybe I'll redo the entire panel then, but for right now, we're just going to concentrate on the 4 additional circuits that we're making for our power wall back behind me in this project. I don't have time to redo the panel right now. And we have lights. It's the same lights I had installed before, but I relocated the switch. It feels a little awkward walking into the back of the shop now and having so much further to walk around to actually hit the switch, but I think it's in a much better location. It kind of frees up that wall for more goodies in the future. Alright, so we're here at the electrical panel, and these are the new breakers that we put in. Now each one of these, this is a single pole breaker. These are double pole breaker. All these are 240 volt. These are 115 volt tandem breakers that we installed. So we got this one, this one, this one, and then this one down here. This 20 amp breaker, just to give you an idea of kind of how we how I set this up and why I did it this way was these 20 amp breakers are obviously the electrical outlets that we deemed circuits 1, 2, 3, and 4. So as previously mentioned, we'll have split circuits. So on the 2-gang box, the left outlet will be circuit 1, the right outlet will be circuit 2 for the first 5 outlets, and then the further along down the wall we switch to circuits 3 and 4 with the same setup being 3 on the left and 4 on the right. That way I can plug in 2 high amperage things such as a fan and a vacuum or a chop saw and have everything running at once and have no fear of tripping a breaker or overloading the outlets. This 15 amp breaker that you have here, and this is just a tandem breaker, not a double pole breaker. There is a difference. Double pole breakers are 240 volts. They have one leg of 120 apiece, and they send 240 volts to whatever you're working, such as air compressors, high voltage, things like that. These over here operate on the same leg of the panel, and they're just 115 volts, but they allow 2 circuits to take place of a 1 circuit space. So it allows you to maximize the space in the panel, especially on retrofits and things where you're running out of room. It allows you to add additional circuits without adding an additional sub panel or something of the like, or putting in a whole new panel. So these 15 amp breakers I've got just for the lights, and that's why there's a gap between these 20 amp breakers. Here's your main breaker, and you'll have 2 inputs. I'm not going to get too close because it is a live panel right now, but these main wires leading into it, they're 120 volts apiece. That feeds 2 main bars that feed the panel all the way down. And just because something's on the right doesn't mean it's being fed by the right bar or the left bar. They actually do intrude over and stick up on this side, and the same thing over here. So every other space in this panel is fed by a different bar. So this top space right here with this 20 amp breaker that has circuits 1 and 2 on it, there are 2 separate circuits, and we'll call that bar 1. This is being fed by bar 2, which is our 2 15 amp circuits for lighting. And this will be fed by bar 1, which will be circuit 3 and 4 for our outlets. So we have circuits 1, 2, 3, and 4 for our electrical outlets. We have the LED shop overhead lighting, and then we have the recessed portion, which is like the round LED can lighting. I wanted those on separate circuits because I have 26 50 watt LED lights on this, and it's probably drawing about 11.5 amps, and I didn't want to put those all combined. Another reason that I wanted this 15 amp circuit by itself was I wanted the recessed lighting and attic lighting on a separate circuit so I could add additional lights. Those little recessed can lights don't take up too much amperage, so I knew I had some room to go to hit 15 amps on this. You don't want to draw any more than 80% on whatever rated breaker you're using, so about 10 or 11 amps on a 15 amp circuit's good. About 16 amps on a 20 amp circuit is safe. Anything above that, you run the risk of overheating the wire or tripping the breaker constantly. So this 15 amp circuit has all 26 4-foot LED shop lights that are strip lights on its own, with one switch controlling all that in the back. This 15 amp circuit goes up, it feeds the attic lighting, which only has one keyless outlet with a light bulb in it right now. We're going to add a bunch more in the future, but for right now, I just wanted to get it out of the electrical switch box and up to a part where I could start tying off of that and making a run of multiple chain keyless outlets or whatever else we got to do up there in the attic. And then it leaves over there, comes down the wall, and feeds the switch for the recessed LED can lights in the back half of the shop. And again, these are fed circuits 1, 2, 3, and 4 of the outlets. I have those on the same bar, so they're being fed from bar 1. Okay, we'll call it. Bar 1 is feeding this one, bar 1 is feeding this one, and we have 1, 2, 3, 4 circuits from bar 1. The reason I put the lighting on bar 2 is so that when you have a high amperage draw, like a shop vac or a fan or a chop saw kick on, most shops you'll notice the lights dim, and that's typically because they're being fed by the same source. So if I had a 20 amp breaker right here, and then the other 20 amp breaker was right here, and then I put the 15 amp breaker, down below, this will be bar 1, bar 2, bar 1, right? So instead of having all the outlets on bar 1, I would have outlets and lighting on bar 1, because I would have the 20 amp breaker right here, which will be bar 1, bar 2, bar 1. So 2 and 1, I got outlets up here and lights down here. So this is bar 1, this is bar 1. I'd have two 20 amp breakers, circuits 1 and 2 on bar 1, and then I'd have circuits 3 and 4 right here where the 15 amp lighting breaker is now. And then you'd skip down and I'd have the 15 amp breaker right here where circuits 3 and 4 are. And so that would cause an issue if I'm using something on circuits 1 and 2, and every time I hit the trigger on a Sawzall or a chop saw or something high amperage, the lights being fed by bar 1 down here would flicker and dim, and that's just annoying. So that's something I didn't want. And the biggest reason I split all this up and added all these circuits is so that if for whatever reason something is overloaded and I trip a breaker and the lights go out, I don't want to have a piece of machinery or equipment or something plugged in the outlet that caused the overamperage condition, and now that chop saw or reciprocating saw or something that can, cut off my digits is spinning down while I'm in the dark and can't see anything. So that was the main reason for splitting all this up, just in case you're wondering. But for right now, we still have to hook up all the outlets in the back half of the shop. All right, moment of truth. We're gonna see if all our hard work paid off. All right, this is circuit 1, circuit 2, circuit 3, and circuit 4. All right, that's it. We got 10 2-game boxes installed on 4 different circuits, with the outlets on the left side being circuit 1, the outlets on the right side being circuit 2, and after 5 2-game boxes down this wall, we switched to circuits 3 and 4, all powered by different tandem breakers from the breaker panel to allow high amperage shop equipment to be used simultaneously without any fear of overloading or tripping circuit breakers. We have them independently wired with separate circuits for just the lights. The lights themselves are on a 15 amp circuit breaker, and then we have attic lights and our recessed can lights on another 15 amp circuit breaker, because we have 26 4-foot LED shop lights that draw, they're about 50 watts, and they draw just under a half an amp. So doing the math on that puts us just under about 11 and a half amps, and that's right at the maximum limit on what you want for safety wise on a 15 amp circuit. You want no more than 80% amp draw on whatever rating the breaker has, accounting for startup and things like that. You don't want 14 amps of permanent draw on a 15 amp circuit. That's not good, that'll overload it. Bad things will happen, maybe electrical fires and things like that. Obviously we have breakers in place, but we don't want to push the limits. That's why we split everything up. One of these days I'll get around to throwing an amp meter on it and seeing just how much these 26 lights are actually drawing. That's what they advertise them to draw, is between 0.41 and 0.47 amps. They say they're drawing 43 amps in what the box says, not what I've actually tested, but it should be just over 11 amps. So 11.2 amps for 26 of these LED shop lights that you see above me. Those can lights, the recessed lights, those are LED halo pop-in lights. They don't draw hardly anything. And I have 8 of those in the recess, so we're probably talking a couple amps at best. So on that circuit, I decided it was going to be a good idea, while I'm wiring and everything, to go ahead, add a light switch, put some receptacles for lights in the attic space as well. All we have is one light up there right now that I just installed during this project. I'm gonna get around to installing a bunch more in the future, but obviously this was the main concern right now, so I just took care of that while I was at it, right? So the other major change that I did was relocating the light switch and dimmer switch. This was the shop light switch, and this was the LED recessed can light switch. This had a dimmer on it, and I thought it would be a lot more useful than it was. The idea behind that originally, when I first installed this, was that I didn't want, if those lights were too bright, for me to be working underneath the vehicle, still need some light on top for whatever reason, and be blinded when I was looking up. So I wanted to be able to dim it, and that didn't really pan out. There was never really any time that I needed that. So I decided to go ahead and change it, just put a normal switch in here, and that's all we did. We kept the same layout, with the first switch on the left being the LED shop lights, the 26 4-foot LED shop lights. The second switch is the 8 recessed can lights over the lift area. And again, that's just on a normal switch with no dimmer. This switch over here, we're saving for a future project. So I've already got it wired in. It's hanging out up there in a junction box, capped off, and ready for the future. So we'll get to that at a later date. Obviously, I still have to put all the trim and wall plates and everything on here. I did go with Decora, if you're asking. I'm not a prima donna or anything. I like the flush look, and I like being able to smack the light switches on instead of having to, flick it up or down. Call it what you will, but I like being able to smack the switch, just like you should like smashing the like button for the YouTube algorithm. So it really helps the channel. It helps these videos get recommended to other people who maybe haven't had them recommended in the past. So if you like this kind of stuff, go ahead and just turn that little thumbs up button blue. I would greatly appreciate it if you would. So thank you. The next thing I'm going to have to figure out is what sheathing choice to go with. Probably not going to go with drywall, because this is a shop. It does, you see me pressure washing in here and stuff like that. I don't really want sheetrock around that. So Probably going to be a wood product. I'm thinking somewhere in the lines of 1/2 inch to 3/4 inch plywood. Probably going to be 1/2 inch plywood just because we have studs every 16 inches. And buying 1/2 inch plywood will save me about $5-6 a sheet. So as soon as I figure out what thickness of plywood I'm going to go with, I'm going to go grab all those materials, plywood this thing up, maybe slap a coat of white paint on it, and then we'll figure out any kind of storage ideas and workbench countertop ideas in sometime in the future. So like I said, I don't really know. I got 46 feet of wall going this way and another 7 coming out this way that I don't really have any idea how I'm going to organize it, how I'm going to set it up. I'm going to have to ponder on that for a while. I know these last couple of videos have been a lot of shop projects, but hopefully you guys enjoy watching this stuff just as much as you do the automotive stuff. I know it's just me, messing around in my shop, but these projects are just as much fun for me to do as mechanical stuff on cars or machining stuff and metalworking and things like that, or woodworking. We do have some mechanical stuff coming up. I got to do some work on the forklift. It needs some severe attention. And obviously we still have our 1978 Datsun 280Z that we have not finished yet. So we got to get back on both of those projects. I don't like when mechanical things are broken. That's why I do this channel to begin with. So right now my forklift isn't running, and it hasn't been for quite some time, and I've lost a lot of sleep over that. So I'm going to try to get in there and diagnose what the problem is, hopefully get it running again. If not, I kind of know the next step, and that's going to be an engine rebuild. So hopefully we don't have to go down that path, fingers crossed. As always, you guys know what to do. Please consider destroying that like button. If you have any questions about what I did or why, leave a comment below and I'll try to get back to you as soon as possible. If you haven't subscribed already, please consider doing so. It's much appreciated as always. And until next time, thank you so very much for watching this video.